All right, hi. So here we'll try to learn how array broadcasting actually works and why it is actually required. Okay, what is array broadcasting, and using NumPy how we can do it. Right. See, when we have to do some operations, okay, on the matrices, obviously, like if we use a NumPy, let's see, I'll create a NumPy array over here. Okay, import NumPy as NP. Okay, so I'll create an array over here. Let's say n1 is equals to np dot array. Okay, and thereafter 1, 2, 3, 4. Okay, so this is my first array, right? So this is just a single one-dimensional array, right? Now, when we have one-dimensional array and I want to do some sort of operations, okay, like for example, let's say I have another value represented as a scalar value, right? Let's say this is represented x is equals to 2. Okay, now when we do the operations, okay, like print n1 multiplied by 2. Okay, so what we get, you can see the output that we are getting. Okay, so what exactly happens? Okay, let's try to understand this thing, the process that happens over here step by step. Okay, so see what happened over here. We have a matrix 1, 2, 3, 4. Okay, but the value that we had used over here for multiplication is 2. Okay, so this is a scalar value, this is having four values, both are having different shapes. Okay, the first variable is having four value in one dimension, second variable is having just one value. So here broadcasting came into the play. Okay, so here what it does, you can see here the 2 will be kind of appeared for 4 times, so that 2 can be multiplied to each entity into the n1. Okay, that is what broadcasting do in NumPy array, right? So that is what I had written over here. Broadcasting allows us to perform arithmetic operations on array of different shapes. Okay? Here, the mechanism stretches a smaller array to match the shape of larger array without making an actual copy of the data. Okay, so actual copy will not be created. Just stretch it. Okay, during the processing, it will not get a actual copy, because if it will create a copy after stretching, it will use some resources in the background. Okay, and that may not allow the other things to get stored. Your memory consumption will increase. Okay, so we will get an enable core efficient computation. Now there are some rules. Okay, first of all, it will compare the shapes. Okay, it will start the compare starting with the trailing dimension. Trailing dimension means what? The dimension which is lesser. Like this is having a lesser dimension, just one value. Okay, start with the trailing dimension, compare dimensions one by one. Okay, and then after compatible dimensions. Okay, so dimensions are compatible if they are both are equal. Both are equal means what? Let's say if I have over here n1 or n2 is equals to np dot array. Okay, let's say here 3, 4, 5, 6. Okay, and let's say y is equals to what? Np dot array. Okay, let's say 2, 1, 3, 1. Okay, so both are what? Equal. Now here if I do this thing, okay, it will easily do the operations. 3 will be multiplied with 2. Okay, 4 will be multiplied with 1, 5 will be multiplied with 3, 6 will be multiplied with 1. Okay, so if the both of them are having a same dimension, then obviously it will work. Or one of them is 1. That means at least one dimension is what? 1. Okay, now what it means? Okay, so we had seen how a scalar actually works after the broadcasting. If you want to do mathematical operations on an umpire, we had seen how if both the dimensions are same, then how it works. Okay, now let's go ahead and let's increase over here. I'll define n3 over here. Okay, and we'll just use one more value like say 2, 4, 5, 6. Okay, so now this is what this thing. Okay, now let's try to print over here n3. Okay, and then let's print shape of n3, right, which is n3 dot shape. Fair enough. And let's print over here y. Okay, and let's print shape of y. All right, let's say I'll put it over here y dot shape. Okay, now let's see the output. Okay, let's try to add a gap between them. So see, here we have a 2 cross 4 and it is just 4. So other will be what? We don't have the other one. The other dimension is what? It is a single dimension. Let's do one thing. Let's put it into 2 dimension. Okay, you can keep it 1 dimension as well. That is not a problem. So here one of them is what? 1. Okay. Now when we try to do the operations over here, how will it operate? See, this thing will get what? Broadcasted, okay, for one more time. Like it is already 2131, 2131. Okay. So now we have 2 rows, so it will be broadcasted like this, 2131. Okay. It will stretch itself to match the shape of larger dimensions, right? Or the having a to match the shape of bigger array. All right. So now let's try to do the operations over here. If I try to do operation like print n3 multiplied by 1. So what will happen? You can see 3 and 2 multiplied by 2, 4 and 4 are multiplied by 1, 5 and 5 are multiplied by what? Again, over here 1. So you can see over here, 3, 4, 5. Okay, let me use something different over here. Let's see, I use over here, it's 3, 4, 5, 6. So let's use 3, 4, 8, 7. Okay, let's try to make a little change over here. 3, 2, 1, 8, 7. Okay. All right, because same value we are getting. All right, so you can see the things. Okay, so here 4 and 1. Okay, this 4 and 1 is what? 4 and 1 is multiplied by 1. Okay, 4, 5 and 8 is multiplied by 3. 6 and 7 is multiplied by 1. These guys are multiplied by what? 2. Okay, so this is what the number of rows here in like this thing is broadcasted for one more time. Okay, now let's take another condition over here. Let's say I'll copy this whole thing. Okay, and I'll define it over here as a n4. Okay, and this time what I do, I'll just use over here 3, 4, 5, 6, and here we'll do what? Here instead of using 2, 1. Okay, let's see. All right. Now let's say what we have. Here we have this thing. Okay, 2, 1, 3, 1. Right. Now if I try to do operation over it, will it get operated? Let's see. Print n3 multiplied by 1. Okay. It is not get operated because both are having 2 cross 2. Okay, so here it is not compatible. It will become compatible. Okay, it will become compatible if I'll make a small change over here. What change? Let's say instead of using 2, 1, let's say I'm using only 2 and 3. Okay, so now what change I did? Now one of the dimension is what? 2 cross 1. Okay, earlier it was 1 cross 2. Okay, it worked with 1 cross 4. Okay, like one of the what I wrote over here, at least one of them is 1. Okay, so when it is 1 cross 4, it worked, right? Now when it is 2 cross 1, then also it will work. Then how will it work? We have 2, 3. So those 2, 3 will be repeated for 2, 3. 2, 3 will be stretches over here. Okay, for according to the larger matrix. Okay, and here the broadcasting works in this way, right? So let's try to operate over here. Print n3 multiplied by 1. So when we do this thing, you have what? You can see 3 and 2. Okay, this 3 is multiplied with 2. 2 is multiplied with 3. Okay, so we get 6. 4 is multiplied with 2. Okay, 1 is multiplied with 3. 5 is multiplied with 2. 8 is multiplied with 3. 6 is multiplied with 2. 7 is multiplied with 3. Okay, and then the result we get over here. So in this way, whenever we have a data of different dimensions, okay, and we want to do a kind of operations between them, so in that case, broadcasting can help us to do the job. Okay, and this is not just for multiplication. We can perform it for what? For the addition or some other kind of operations as well. Whatever the operation that we want to do, we can perform the operations on that. All right. So that is how it works. Okay, I hope you understood the